some geometry. Okay, doesn't matter. Yes. Now please change the size. See, okay, here in the variable, this $L. Now let's put 30 millimeters. Okay. Then it's mean in this case that we consider that here this is $L and this is the size of the unit. This is $LL. It means that if we put this infinite rate, it means that we have next another antenna with the same configuration. Here we have another antenna with the same configuration. Here we have another antenna. Here we have another antenna. Here we have another antenna, because it simulates to have infinite numbers of elements. Okay. Now, what is the important thing here is to control what? This size and this size. Okay. Remember that normally this distance let us to control the radiation. Okay. In this case, 30 is too small. This size actually is too small, 30 centimeters, because it means that the other antenna is very next. We need to separate a little more. Okay. But we will change this in the simulation. Okay. Now, the important thing here is the scientists discover this thing. Okay? This is the, or we can say not the length of the patch. Okay? And here we have the angle of reflection. Okay? Then, in the L ideal, the L ideal is the length of the frequency that we want to work. The phase is exactly 0. What does it mean? It means that if we have here this array, and here we have the antenna, for example, the core antenna. If we radiate in this direction, the reflection is 0. I mean, the reflection will be where? In the same direction. But if we change the size, the radiation will change like that. From 180 degrees to minus 180 degrees. Okay? I mean, if we put a smaller antenna, okay, the angle will be produce this radiation. If we increase the antenna, the reflection will be to this direction. Okay? That is very. Then now we need to define only one frequency, because the antenna will work only for one central frequency. In this case, we design this for 3 GHz. Okay? Then here in the analysis we put 3 GHz, and the sweep we define only one frequency, that is this 3 GHz. Okay? Let's eliminate this, and we only consider one single value. Only 3 GHz. 3 GHz. We can generate surface current. Okay? We update and.
Amigo, estoy aprendiendo.
Okay, then we have only one frequency. Okay? Now, there is no excitation. That is the next step. We need to excite, we need to put a field. But the field is not in this structure. The field is outside. because we have a wave that we arrive to the reflection. Then here in the excitation we put right click and we choose the only one that we have, a plane wave excitation. It's mean that here in this detector we have a wave plane excitation. Okay? Now we need to make the simulation, but to be or to have these results, we need to change this length of the patch L. Then for that we need to parameterize. Then we need to go to geometrics, right click, and we need to add a parametric simulation, and in this case we need to add, and we need to change L. Okay? Then to change this, we're going to change, remember that in theory, the central length of the ideal length is 23.49 millimeters. Then we need to vary this from 22 until 25. Let's put like that. I mean, a huge variation. And step 0.1. Yeah? We add and we put OK. Let's put OK and let's simulate. I don't know about the result now because the size of the cell is very small. Do you remember this, Lopez? Ah, come on.
Repeat next semester.
Don't worry, next semester you will understand better. Huh? At the beginning, this must be bigger. Okay? Normally, remember that this antenna to this antenna in an array, normally this is 0.65 with length, that is the normal size. Okay? Then we need to increase this because this is very small. Okay, but this is only for simulation. Okay? Yes.
How is it? Toca probar el elefante, ¿no?
We need to change the axis. Let's go first to sweeps. Okay, here there is only frequency, but we need to check all the another parameters. What parameters we need? L. Okay, then we choose L, all values, and in X, we go to X first. Yeah, in X, what we need? Not frequency, we need L. Exactly, that's our, okay? No, in angles. I mean, we need only, where is, okay, there is not because we need to put exactly the result. No. Okay, let's see here. Okay, let's check how is the result. Okay, just put done. Okay, then if you look at this, okay, you can check how varies the reflection coefficient, that is like S11, for the sizes. Then here, for example, you can see that for this frequency, the best size in theory is this one, that is not 23.49, is this one. Okay? Then it's meant that this will be normally the best size for the central frequency, 22. Okay?
Es el otro.
Okay. Then it's mean that it's exactly 22. There is not 23.
¿Puedes repetir?
Okay.
¿Cómo se puede repetir?
Oh, yes, easy, teacher. Easy. No problem, professor.
¿Qué hace muy rápido?
Okay. Let's do once again. Go to results, eliminate the result.
Elimínelo, joven.
Let's put another one. Okay, we go to sweep first. Okay. In the sweep, we use different things. We use in this case $L because we need $L for difference L. In X, we need to don't use the use primary. We need to use the $L. And in Y, in this case, we use the reflection coefficient E. Okay, this is only to determine. Okay, no, a trace. This is only to determine, in theory, what is the best size of the antenna for this frequency. Okay? Now, we put another plot. We go to result. Okay, create report. Same. Okay, we do the same in sweep. We use difference, I mean, we have $L. In X, we use different, we use $L. Come on, man. Yeah. And in Y, we don't use now dB. What is important for us is the angle. Okay, at trace.
En grados.
Okay. Then, in this case, what is the value that we need? Is this angle 0? That is here. Then if you see here, the dimension of the antenna
Pero el
is in
centro no
22,
tiene que estar en
17,
23, 49.
Pero se está igualando.
79 more or less.
No, 23, 20, 22 punto.
Millimeters. Okay? Then it's mean then for 22.79, when we put here 22 for 79 millimeters, if I receive a wave in this direction, the reflection will be exactly in the
Same.
same direction because the angle of reflection is 0. Okay? If we decrease the size, what happens if we decrease the size? The angle is positive. Okay? I mean, if we set 0 degrees, the reflection, if we decrease, for example, to 22.50, you can see there is only difference of 0.2 millimeters, very small, 200 micrometers. Okay? The reflection will be what? Okay? In this case, is this, that is 55 degrees. Okay? 55 degrees. Then I mean only because we reduce the size, the angle is
Increase.
different. What happens if we increase the size? If we increase the size to, for example, 23, the angle will be 25 degrees, 30 degrees, but in the other size. Only because we increase from 22.8 to 23. I mean only because we increase 0.2 millimeters, the reflection change the angle. Okay? Then what happens if we want, okay, to radiate, for example, we have here, let's do like that. Okay. I will put here the antenna. Okay. And we need to radiate in this direction. I mean, for example, 50 degrees. How we do that? If we send this antenna, this part, the dimension to have 50 degrees is what? Is 22.50. The size is 22.50. What happened with the next patch? In the next patch is what? This is the angle. Okay? And this is the reflection. This angle is 50, but we need this another angle. What is this another angle? Okay, we need to determine in geometry. That means we need this dimension B1 and this dimension B2.
Two.
And we calculate what? This angle. Then let's put just an example. We say that this is 30. It means that the angle of the reflection is not 50, is how much? 80 degrees. We go to 80 degrees and we define what is the angle. In this case, is 22.3. Then the size of this element is 22.3. Okay? Now, let's work with this. We send a wet plane to this direction. And we need this angle that this is 50 degrees. We say that is symmetric. Obviously, for this example, we say that this is 30 degrees. Then here, we have what? 30 degrees. Then the total angle of reflection is what? 20 degrees. Okay, then we go to 20 degrees.
20.
We go to this dimension, and then the size is 22.7. Then the size of this is
22.7.
Okay? It means that we need to calculate element by element. Okay? And this simulation only give us what is the reflection angle to take in account when we design each element by each element. Okay? Once we defined, okay, these sizes, we can eliminate that and we can put like that. This element is 22.50. 22.50. This upper element is 22.30. This is 22.30. And this dimension of main cell is 30 millimeters. This is another 30 millimeters. This another element is
22.70.
22.70. This is 30 and this is 30.
No
With
cambia.
this array, if I put the antenna here, all the radiation will be in this direction. Okay, with this structure. Okay, obviously, we can change the dimension of the cell. I mean, in this example, this cell is how much? 30 millimeters. Let's change, please. Let's put 35 millimeters. LL. No. Okay, you can put that, it doesn't matter. The main important is this one, that we work in this case with 30. That is very close. We need to increase that. Let's put here 35. 35. 35. 35. 35 millimeters. That's all. Okay, then it's bigger. Let's simulate once again to view the result and to compare the results. We need
En GI
five.
siempre se va a calcular, como dijo, elemento por elemento, no hay una fórmula para poder calcular varios elementos a la vez.
Yeah, there is now a theory. Okay, all these reflect this new theory. Okay, new theory we said 15 years, 10 years ago, but it's new theory. Okay, and there are some new books to explain exactly mathematically, but we need a complete course to describe that. Okay, in this case, for this course, I explain you only in experimental way.
Ah,
Okay, if you need more, there is a lot of new books, completely new books.
libros antiguos.
Okay, I will put in
Es que
the
sí, pues.
a learning paper or a book I have. Yeah.
No lo sé. Ya, gracias.
No, easy. This is your breakfast. Increase the size of the antenna to reflect zeros. I mean, you can see here it's more or less in this point, and this is in 23.05, where we have zero reflection. Okay? Then you can see in this zone is the same, or in this zone it will be the same, but the most important thing is here. Okay, that you can analyze how it changed this and how we change this. Okay, to determine which one is better. Okay, then Merino, tell me which is better for you to use. 30 centimeters or